So the Generation 3 Alpha reactor is our newest reactor, and the breakthrough for our catalyst here is the scale. So we have developed the technology of making valuable carbon materials such as graphite and nanotubes from CO2, but now for the first time we can actually deliver kilograms of materials in a couple of hours. And that is a big step for us because it is the first step of having an industrial cell size of the electrolysis process ready to be scaled into multiple cell sizes. It is very important to scale for us in rather large steps because our technology is a technology that makes commodity materials such as graphite and nanotubes. And the supply chain for these materials requires you normally to supply thousands of tons in 1 year. And there's no in between. You cannot supply just 10 tons or 20 tons or 30 tons. You need to immediately jump to a very large quantity. So scaling from our Generation 3 reactor to a Generation 4 reactor is the first step to immediately scale higher to kilotons per year. So what it does in a nutshell is it takes the CO2 molecule and it takes the carbon, puts it on one side of the reactor and takes the oxygen on the other side of the reactor. And this is done by a process called molten salt electrolysis. Electrolysis you might know from water electrolysis or hydrogen electrolysis, where you make hydrogen out of water. This is very similar, but we make carbon out of CO2. So we use electrons, 4 electrons per carbon atom, to take the carbon atom out of CO2 and put it back into the form of carbon. And depending on how we run our process, which voltages we use, which currents we use, we can make either graphite, which is a battery grade material, or we can make nanotubes. So both are carbon, but both are carbon atoms arranged in different formats. So the next steps in the upcoming years are all scaling steps. So for us, of course, we are developing the technology further as well on the basic level. We are improving the process efficiency, we are improving the quality of the product. We are investigating whether we can make nanotubes even longer or even thinner. But for us, the really important steps over the next years are to scale the technology further. So to move from 2 cells in this Generation 3 Alpha to 10 to 20 cells in a large Generation 3 reactor, and then to move to a large continuous process in our Generation 4 reactor. Biggest lessons learned is as always, when you make plans, then these plans normally hit reality at some point and you need to adjust. But it's the case with any deep tech scaling up. So you need to adjust your plans on the way, especially when it comes to things like suppliers and lead times. So we have designed this reactor ourselves, we have built it ourselves, but of course we are still dependent on suppliers that supply us parts or materials. And there we have learned a lot about how to make our plans more resilient against delays. We have been slightly delayed with this reactor, but actually only a couple of months, which for these projects is quite good, I would say. And the other lesson learned is really that talent counts. So if you have the right people in the room, and we have an amazing team here at Catalyst, especially in the engineers that worked on this, the scientists that figured out the processes, that came up with the calculations, then you already are halfway there. If you have that team, you can do it. Then it just depends on good planning.